Session 41, theorem number 3. A function which is continuous in a closed interval takes every value between its bounds at least once. Proof. Let f of x be a continuous in the closed interval a comma b, and let capital M and small m are LUB and GLB of the function f of x in closed interval a comma b. Clearly small m less than capital M. Let k be any arbitrary real number such that m less than k less than m by theorem 2. It follows that there exists at least one point x1 belongs to closed interval a comma b such that f of x1 is equal to m. Similarly, x2 belongs to closed interval a comma b such that f of x2 is equal to capital M. Consider the function f of x defined by capital F of x is equal to small f of x minus k. Clearly, capital F of x is continuous in the closed interval a comma b, as the function f of x is continuous in the closed interval a comma b. Also, f of x1 is equal to f of x1 minus k is equal to small m minus k, which is equal to negative since m less than k. And also, capital F of x2 is equal to small f of x2 minus k is equal to capital M minus k, which is equal to positive since k less than capital M. Therefore, capital F of x is continuous in closed interval a comma b, and f of x1 and f of x2 are of opposite signs by using the theorem. If f of x is continuous in closed interval a comma b and f of a and f of b have opposite signs, f of x vanishes for at least one value of x belongs to closed interval a comma b. That is, there exists c belongs to closed interval a comma b such that f of c is equal to 0. F of x vanishes at least once in closed interval x1 comma x2. That is, there exists a point c belongs to closed interval x1 comma x2 such that capital F of c is equal to 0. Now f of c is equal to f of c minus k is equal to 0 is equal to f of c minus k, which implies f of c is equal to constant k. Thus, the value of k being any number in between small m and capital M, it is attained by the function f of x at the point c belongs to closed interval a comma b. Hence, the function which is continuous in a closed interval takes every value between its bounds at least once. Hence, the theorem is proved.